Alrighty, so let's get into this here. All right, shouldn't take too long here. All right, to go through this, I hope at least, because it's mostly review anyway, right? But rational expressions, simplifying them is the name of the game today. So let's take a look here at a couple things. We're going to look at just simplifying straight up, and then we'll talk about adding and subtracting, multiplying, dividing. Then we'll kind of put it all together for like a problem or two, and then that'll be it. All right, so let's do this here. So we'll just start out here with the kind of like generic directions of simplify, right? Simplify in math can mean a lot of different things depending on the scenario that you're kind of given, what comes next here. All right. Typically, for our purposes, it's going to be like, seeing if you can get things to cancel out, seeing if you can get things to add or subtract or multiply or divide, so you can get it from two, kind of ideas to one kind of thing. That's what we're going to be kind of looking at here. All right. So let's take a look at one. All right. So we want to simplify this thing, right? So running across something like this, right, we want to see if we can simplify it. So we think about how we can cancel things out here. Can I, for example, cancel, I see I have an x cubed and it's over an x. Can I cancel the x cubed and the x and make this x squared over 1? Can we do that? Ooh, not a resounding yes or no there. We're unsure. Okay. Well, so we're unsure there, okay? What are some things that we're sure we can do here, though? I think we're not sure if I can cancel out that x cubed with the x there. What are some things we can maybe do here? Natalie? Factor an x squared out of the top. And we're sure we can do that, right? We definitely do that in the past. And so if I factor an x squared out, I'm left with x plus 1 left over there. Okay? And now that I factor that x squared, is there anything else we can do to simplify? Is that the best we can do? Uncertainty still. Jenna? Okay, so cancel the x plus 1s. So that goes together and just say boom like that. That cancels there. And so we'll say our final answer then is x squared. Like that. And yes, that works. Okay, I'm going to throw in just this little argument here that, of course, these three things are equal as long as x is not equal to -1. Okay? Do you need to put that there? No. Okay? But I think it's good to understand that it should go there and why it should go there, right? Because -1 in the original expression here, -1 in the original expression would give us undefined, right? Or 0 over 0. Here, -1 doesn't give us a problem at all. And so they're not exactly equal everywhere. At -1, they're not exactly equal. Okay. So that's it. Good. Now, let's go back, though, and talk about what I asked about earlier, right? We had x cubed plus x squared over x plus 1 like this. And I asked, can we just cancel out the x's and x cubed and x like that and make it x squared plus x squared over 1 plus 1, I guess what that would be. So that would make it 2x squared over 2. And, oh no, Mr. Wid, I shouldn't have gone this path. Because we get the answer that we should have gotten, but that's not good math, okay? So, well, it doesn't work. You'll just have to take my word for it there. But unfortunately, in that one case, it did work, okay? It does match up. But no, you don't want to do that, okay? Because when you divide, right, got a big fraction like this, okay, you have to be careful. You can't just divide like individual terms. It has to be a product. So when Natalie factored out that x squared here, we now have a product of two things. And so then the x plus 1s can cancel and leave you then with the x squared. Okay, you can kind of think of this maybe as like, we can break this up as x squared over 1 times x plus 1 over x plus 1, right? This would be equivalent to that. And so then the x plus 1 is exactly canceled, giving you a 1, and so you're left with x squared over 1, or just the x squared there. Okay. But yeah, you want to be very careful when you have the addition. Okay, you got to make a product before you can cancel out from the numerator and denominator. That was bad. Oh, well. All right, you guys try this one. All right, try this one here. So x squared plus 6x plus 5 over x squared minus 25. So go ahead, try and simplify that. All right.
Can't read it, and I don't have my glasses because I use them for the driving test and put them inside.
Oh, and they're now somewhere else.
I did pass the driving test though.
Well, that's good. That's good. All right, well, let's go to someone here. Let's see. I think I picked Ro. So, Ro, what did you do here, or what could we do here to simplify this?
I don't know. I didn't do it.
Didn't do it. Okay. How could we do it, though? Any ideas? Like, what could we do with this numerator here?
Can't read it.
Can't read it. Oh, okay.
I don't have my glasses.
I gotcha. All right, you want to take a look, take a gander real quick, and then see if you can come up with something here? You can zoom in some, too, if you need to, but you're good now? Okay. So again, what can we do here to factor, or, well, negative away, right? So, does the numerator factor? Can you get it to factor?
Brain's not working.
Okay. Can you factor the denominator? X squared minus 25, would that factor to be? And if you're not sure, that's okay. Not sure?
Yeah, because
So yeah, this is a difference of squares, and so this would factor to x minus 5 and x plus 5, like this. Okay? And so then we're looking for, here to factor this, we're looking for two numbers that multiply to 5, but add to make 6. So what are two numbers that multiply to make 5, but add to make 6? 1 and 5, you got it. So x plus 1, x plus 5. There we go. Okay, and then Ro, does anything cancel out here? Yes. What cancels? The x plus 5s do. Right. And so we're left with x plus 1 over x minus 5. Very good. And I'm gonna also just stipulate here x not equal to the negative 5. Okay, right. So the reason why I say negative 5 here is that for our final answer, negative 5 is okay in this, right? Negative 5 is okay to plug in here. Negative 5 is not okay to plug in here. It's not okay to plug in here before I canceled. All right? You're right. 5 is restricted, but that restriction is still there for this and this and this, right? So this one, it would still be understood that the 5 is restricted. But because we eliminated that x plus 5 factor, we now no longer, kind of have it there. So we need to describe, x not equal to negative 5, right? This and this are not exactly the same, okay? This one and this one will be the same at positive 5. They'll both be undefined. But this one will be 0 over 0 at negative 5. This one, we get an answer at negative 5. So you see the difference there? So it's okay. I don't need to put x not equal to 5 here. I'm not describing the domain. I'm saying these two things are equal everywhere except at x equals negative 5. So that's all. Okay. And that's a subtlety again. But that's, it is important. And that's a good argumentation there. I hear what you're saying. Okay? All right. Let's talk about adding and subtracting now. All right. So again, we'll just have the directions of simplify here. So 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. Okay. So, again, think about these rational expressions as just like glorified fractions. Okay? They're really just fractions. And in order to add or subtract fractions, what do you need? Common denominator. Exactly right. Do we have a common denominator here?
Yeah.
We do, right? We got the same thing, x squared minus 9. So we can go ahead and put these things together. Now, this minus in front of the fraction, all right, this minus sign in front of the fraction, it distributes to both terms up here. So I'm going to write this out kind of with maybe more steps than you normally would, just so you can kind of see it here. Okay. I'm going to put these two fractions together over the x squared minus 9. I'm going to leave the 5x plus 1, but then subtract the quantity 4x minus 2. Okay? That minus sign distributes both to the 4x and to the negative 2. So it really becomes 5x plus 1 minus 4x plus 2 over that x squared x squared minus 9. Okay? So do be careful with that. All right, and now you can combine like terms, right? So we get, what, x plus 3 over x squared minus 9, right? Okay. And so we're done. There's our simplified form, right?
No.
No. Oh, I can't trick you guys. All right, so what can we still do here? Factor the denominator. It's a difference of squares. That's right. Don't forget, you know, we can still cancel things out potentially here. And the x plus 3's cancel. And you get 1 over x minus 3. And now, since I got rid of that thing in the denominator, I'll also put, you know, x not equal to negative 3. Okay, so again, all of these things are equal, except where x is negative 3. Oops, I'm off the screen. There we go. Okay, so our final answer is 1 over x minus 3. Again, 3, positive 3, would give us a domain restriction. It would make us undefined. Okay, but that's a problem here if I put in 3. If I put in positive 3 here, here, or even here, right? If I put in positive 3 at any of these steps, I'm still going to be undefined. But I have to exclude negative 3 because I'm saying that this is equal to this, which is equal to this, this, and this. This one does not have a problem at negative 3, but all these previous ones did have a problem at negative 3. So when I say these things are all equal, I'm saying they are all equal except at that x equals negative 3. Okay. All right. Here's one for y'all to try. X over x plus 1 minus 3x plus 2 over x plus 1. I know I'm making it super easy. Let's see what you can come up with here. Again, just those nebulous simplify directions. This multiply back to give you this. You can factor negative 2 out, but watch your factor. Show you. Oh, I took it away. There, you want to copy it down?
Okay. X
And it's not going to set them equal. This is not an equation.
So,
We're combining like terms. Like 30 more seconds here. 30 more seconds. Okay. Yes, Jeff.
is it 4x plus 2 over 2x plus 2?
So we are subtracting here. We're going to do x minus x, and also minus 2. That minus sign distributes to both terms there. And then
So that means it's negative 2x minus 2.
that'd be negative 2x minus 2, exactly right. And it's over x plus 1. When you combine fractions, the denominator stays
Is
the
that
same.
over 0? That
No.
can't be over 0.
No. When you add fractions, the denominator doesn't change, right? 1/2 plus 1/2 is not 2/4. It's 1 over 1, right?
I see.
Or
So
2 over
it's
2, I should say.
Negative 2x minus 2 over x plus 1.
That's right. And then you can factor a little bit further there. Okay. So, yep, there's our final answer. You can factor out a negative 2 still from the numerator, and you get negative 2 as your final answer. Okay, the x plus 1s cancel. Okay, so it's kind of nice. I mean, I don't know, in my opinion at least, right? It's kind of satisfying. You have something that's just like crazy looking, and it's divides just down to negative 2. Okay, it's kind of crazy to think about. There it is. Okay, and of course, stipulation there, as long as x is not equal to negative 1. Okay, this has a problem at negative 1. This does not have a problem at negative 1. Okay, so they're not quite exactly the same, but when we say equal, equal should mean equal in mathematics, right? So, all right, last little bit here, we're talking about multiplying and dividing, and then we'll combine some stuff together, okay? But I don't want to take too long here with this. So we're going to do some multiplying. We'll do 2 multiplying, dividing, then we'll do some putting it all together. Okay, so multiplying / dividing rational expressions. Okay, so again, our directions simplify. Okay. So let's say we want to multiply x minus 7 over x minus 1 with x squared minus 1 over 3x minus 21. Okay? So, one thing we could do, right, is just kind of brute force this thing and just go in and just start multiplying, right? X minus 7 times x squared minus 1, use FOIL there. X minus 1 times 3x minus 21, use FOIL there, and just go for it. Or, what else could we do here before we just go ahead and start multiplying? Ethan.
Well, it seems that x minus 7 is the multiple. Well, if you multiply it times 3, you get 3x minus 21.
Yeah, so we can rewrite this here, right? So, and also x squared minus 1, we can rewrite that as x minus 1, x plus 1, right? So that factors, this factors, if I take out a 3.
And the x minus 1s cancel.
Right, we can cancel out the x minus 1s, kind of like cross-canceling, just like we did for the warm-up, right? When we were talking about like numbers with these algebraic, kind of like factors and stuff like that, those can still cancel, right? Is that it? What else can still cancel here? X minus 7 can still cancel. Okay. The numerator and denominator there. All right. And so what's left behind in the numerator? An x plus 1. And remember, when we cancel out, when you cancel something out with division, what number is left behind? What quantity is left behind? A 1, right? If there's nothing written, if it exactly cancels, there's a 1. So it's 1 times x plus 1, we get x plus 1. And the denominator, 1 times 3 times 1, so it's 3. Okay? So you can leave it like that, all right? Or you can make it, 1/3 x plus 1/3 or something like that. You can divide it up. Okay, your choice there. Again, stipulation, x not equal to 7 or 1. Okay, in this case. So yes, Jeff. Yeah. All right, let's do one more here. We'll do a division one. Okay, again, simplify here. So x squared minus 2x plus 1 over x cubed plus x divided by x squared plus x minus 2 over 3x squared plus 3. So, of course, kind of like we did for the warm-up, right? Instead of dividing, let's change this to what? Yeah, multiply by the reciprocal. Exactly right. Oh, I probably should have just went ahead and factored as well, but oh well. Okay, so really division is kind of like a made-up operation. We don't need it, right? We could just as easily talk about multiplying by the reciprocal. I guess it makes sense in the context of like word problems and things, but anyway. And then we'll factor, right? So I'll leave the rest to you. Go ahead. Finish it off there. Now that's multiplication, well, we know how to do that. Should be no problem. What's that? Yippers. No offense meant. All right, something like this is what we should have gotten there, okay? I'll leave it up to you whether you want to multiply the 3 through, multiply the x through, or leave them factored, okay? Again, that word simplify, it can kind of mean different things. Just understand that it is something you can do, right? You could distribute the 3 back through, you could distribute the x back through. Your choice, all right? That's okay, whether you do it or not. I'm not going to, take points off because this is unsimplified still. I don't know. I would argue, you could make an argument either way, I think, so. That's my opinion, though. Okay. All right. Now we're going to put it all together, right? So now we're going to put it all together. See what we can kind of come up with here. Because when it comes to things like, again, we'll just say simplify. Okay. When it comes to things like x plus 2 over 2x minus 3 minus 4 over x plus 3. Okay? So when it comes to a problem like this, well, we have to employ a couple operations here besides, or a couple operations besides, just subtraction, the one we see, right? Okay. Can we subtract these two quantities as they're currently written? No, why not? What's the problem? We do not have a common denominator. Right. Okay. So, you can kind of like be strategic sometimes about how you get your common denominator, right? So, for example, if you look at this and you're like, oh, that's a 2x minus 3, and this is an x plus 3, sometimes you can see, oh, if I just multiply one of these by something, I can get the other one. But in this case, there's no real easy way to multiply, x plus 3 by something to get 2x minus 3. Likewise, there's no real easy way to multiply 2x minus 3 by something to get that x plus 3. So instead, we have to kind of revert to kind of like a default way, which is you can get a common denominator by multiplying each denominator by the denominators of the other fractions. This strategy always works. It can get unwieldy, though, especially with these rational expressions. If you have like 4 fractions and they all have different denominators, that can be a pain in the butt. But here we said 2. So, what this is saying, right, is that, so for example, our first fraction here, we have 2x minus 3 in the denominator, and it's missing an x plus 3 in its denominator. So we're going to fix that by multiplying the top and the bottom by x plus 3 over x plus 3. Okay? We do it this way because when we multiply by x plus 3 over x plus 3, what quantity are we really multiplying by? When you multiply by x plus 3 over x plus 3 here, what quantity is that really equivalent to? 1. And if you multiply by something by 1, does it change the value of something? No, right? So we're not changing the value of this. We're going to multiply by just by 1. And then likewise over here, we'll also multiply by 1, but we'll multiply by 2x minus 3 over 2x minus 3, again, to match those denominators up. Okay? And so I'll go ahead and I'm going to multiply the numerators here. So I'm going to go ahead and make that x squared plus 5x plus 6. I'm going to leave the denominator, though, unmultiplied, because it may factor later. And I'll do minus, and then the quantity here, let's see, 4 times 2x is 8x, 4 times minus 3 is minus 12. Okay? So don't forget that minus sign here, which is in front of the fraction, it would distribute to both the 8x and the minus 12 there. Okay? Just like the 4 distributes both the 2x and the minus 3, that minus sign also is 2. Okay? And so let's see here. We can now combine those. So it's going to be what? X squared minus 3x minus 6 over x plus 3 and 2x minus 3. I did not do my math right there. 18 is what that should be. Sorry about that. Yep. So minus 8x gives you negative 3x, and then minus a negative 12 gives you plus 12, so 6 plus 12 gives you 18. Whoopsie, whoopsie. Right. Can we factor that numerator?
Yes.
Does it factor? What does it factor to be? Let's see here. Negative 6 and positive 3. Okay, like so. And the x plus 3's can cancel. And we're left with x minus 6 over 2x minus 3. And again, that's all equal as long as x is not equal to negative 3. Okay. So yeah, so be careful, right? You get all that work done. Don't forget to check to see if you can factor and then cancel again. Okay? In case we were able to do that. Okay. Alrighty. Let me show you one more, and then I'll have you guys try one, and then we'll be done. Okay. Uno más from me. 7 over 5x squared plus 15x plus 9 over x squared, bless you, plus 6x plus 9.
It's 6x plus 9.
The 6x plus 9. x squared plus 6x plus 9. Now, what if we wanted to add these together? Sorry, okay. We could fall back on that strategy I mentioned earlier, right? Where you take your denominator here, multiply it by x squared plus 6x plus 9 over x squared plus 6x plus 9. And then this denominator here, multiply it by 5x squared plus 15x over 5x squared plus 15x. And then, just multiply it all out, combine like terms, et cetera, et cetera. However, we can actually, if we're a little bit careful here, we can find a common denominator without having to do as complicated of the work here. Because this denominator factors. It's really 7 over 5x times x plus 3. And this denominator also factors. It's x plus 3 times x plus 3. Okay? Now when we factor those denominators, we can see, well, they actually have more in common than we thought. In the first step, right, they had nothing in common. So we just had to kind of just multiply, the first one by the second one, multiply the second one by the first one. But now, in fact, we see, oh, wait, they both have an x plus 3. Okay? What is this denominator missing, though, that this denominator has? Another x plus 3, right? This one's only got 1, this one's got 2. So to fix that, we're going to multiply this one by x plus 3 over x plus 3. And I didn't leave myself very much space, so I'll do it like right in here. Okay? And then what is our second denominator missing that our first denominator has? A 5x. Right, so we'll multiply the top and the bottom by 5x. Okay? This is perhaps much easier, right, work to do. Because we don't need to multiply out our denominator. I can leave it as 5x times x plus 3 times another x plus 3. Okay? And then for the numerator, I just need to do 7 times x plus 3, so it'll be 7x plus 21. And then 9 times 5x is 45x. Then combine like terms. And we get 52x plus 21 all over, well, the 5x, the x plus 3. And I'm going to go ahead and just say that's x plus 3 squared, right? Since we're multiplying x plus 3 times x plus 3. Okay. Can we factor that numerator anymore? Yeah, I don't think so, right? 21 is divisible by 3, but 52 is not. 20 is also divisible by 7, but 52 is not. So yeah, we're kind of done there. All right, and there's our final answer. Alrighty. Ready to try one on your own? Yeah, all right. And I'll get you started on the assignment here. So, again, simplify all your directions here. 3 over x plus 1 plus 5 over x minus 1. And it's off the screen. There we go. Okay, so go ahead. Mr. Weird.
There we go. All right, you should have gotten like 8x plus 2 in the numerator over x minus 1 times x plus 1. You could factor 2 out there. Again, doesn't really help. So it's your choice whether which one you leave as your final answer there. It's debatable. I would say about which one's more simple, but I'm sure different teachers have different opinions on that. Okay, I will accept either one at that point. You still should check though if you factor in things if things can cancel.
Mentally, if not by paper. Alrighty, questions on any of that? Okay. So then, what I've got for you on the Google Classroom, it's in the back of the book. So that's like that section, that A section, the appendix.